Hello. Now we will see first order time response. We can see the simulation using LabVIEW. So what we will do is open a LabVIEW. File, new VI. Now when I am saying first order system, we can think of a simple RC circuit as our first order system. So I'll go to the block diagram, control and simulation toolbox. For all the control system simulation, we can have the control and simulation toolbox. Go to control design and go to model construction. From there you can get the first order block. So I'll keep the first order block here. I have kept the context help on so that I can get what are the input points, output points, etc. So what I do when I come here, I understood that I have to give the static gain K and I have to give the time constant. So static gain, if I am taking directly from here, by default the value is 1. So what I do, I'll say create constant. By creating a constant, you get 1 over here. Now the other one is time constant. Time constant. When I am saying RC circuit, the time constant is multiplication of R and C. So I'll give two vertical pointers, slides, one for R and another one for C. So this is my R. I'll change the name to R and I'll change the name here also to C. I'll say the maximum value as 0.0000. This is 1 microfarad, or even I can say 10 microfarad. Let it be 10 microfarad, and the value of R I'll say 100k or 10k. I'll keep it as 10k. So I'll increase the size of and also I can the value of R is whatever value I use the slide. To have a display of that, I'll say right click, say visible item and say digital display. So this digital display is for R. And for C also I'll have a digital display over here. Say visible item, say digital display. I'll get the digital display. Whatever value I am giving here will be displayed on that. Now I have to connect it to the time constant. So time constant is product of these two. I'll have to get a multiplication block, multiply from the block diagram, from numerals, connect R and C to the multiplier, and the output of the multiplier is my time constant, which I'll give it over here. I'll say view as icon. Now I have to observe the time response. So I'll take the time response function. Again, control and simulation, control design. You have time response. In that time response, I have step response, impulse response, etc. First, I'll take step response. And transfer function. We are doing with transfer function model, so I'll change the state space to transfer function. And we know that we have some standard test signals like impulse, step, ramp, etc. So that's why we are using step and ramp, unit step and unit ramp. Now the output here is my transfer function model, which I can connect to the input of step response block. And now I'll say create indicator, which is a step response graph coming up. Now in this program itself, I'll do for the impulse response. Again, go to control and simulation, control design, time response, and impulse response. Again, take the transfer function because we have taken a transfer function model and connect it over here and create indicator. So I got a step response graph and impulse response graph. So this is my block diagram and this is my front panel. To flip from front panel to block diagram, I can use Control and E. I'll keep the input here. Again here also I'll put it on a decoration. These are my outputs. Sorry, I'll have to take the decoration. Anyone you can take. I have taken this one. Select it and move to back. So I got the step response graph and impulse response graph. Now if I run it with this value of R and C, that is, it is almost 2.5K and (1.1 farad. That much microfarad it is. Actually this I have to extend, then only I'll get that 10 raised to minus 6. Now if I run, I'll get the response. So if I increase the value, say to 8K and run, the value changes. We know that for step response, after 4 time constant, it almost reached to the final value, that is almost 98% of the final value, where you have 2% tolerance. Now if I want to continuously run it, go to your block diagram, put it in a while loop, that is go to structures, while loop, and create a control over here. Again flip to your, so I have a stop button coming over here. I'll keep the stop button also here. I'll increase the size of the stop button. Now if I run and keep on changing the value of either R or C, I can see the variation in my graph. So say run. See if I reduce R, the time constant changes. So you can try it out. So this is 1 minus e raised to minus t by tau, where tau is your time constant. Thank you.